Hi everyone, my name is Hirki Anrutsai. I am from VIT Velur, ECE department. And today in this video, I am going to explain my lab task of microcontroller. And coming to the first questions, these are my code I'm going to explain a total of 5 questions in this video. And this is my first question. My first question is to perform the addition of 5 8-bit numbers using Kyle software. And this is the Kyle software and this is the IC pin which I have been using. And the numbers which I have to add is my registration number and it is 19BEC0522. And I have added 0 at the starting to get an even one. And going to 1, this is my flow chart. This is how I am going to start. First I will start and then I will assign the values to the accumulator and I will add the mnemonics and I will shift the values from in A to B and I'll do the same for each and everything and I'll complete my addition and I'll stop the program. And in this table, I have mentioned each and everything like for labels, mnemonics, operands, addressing mode, mission cycle required, memory byte required, types of instructions, comments, flags affected by the types of instructions. See, I have added each and every one of my code and I have explained all these operations right here. And this is the end of the table. And these also I have created also an Excel sheet which is easy to access, and if you want to change you can change it easily in the Excel sheet. And there is the link for the Excel sheet. And the registers containing the result. Register A containing the result which is register 0 has a result of. And these are my manual calculations of the result. And these hand calculations. And this is my code. Coming to the code, I have mentioned each and everything in the table and I have also mentioned the same thing here so that you can understand it easy while reading the code. And I have also given the comments so that you can understand the code by line easily. And you can see here I'm adding my registration number 19BEC0522. And that's my code. And of the execution, these are my registers. And this is the result of the execution. And these are the time period and mission cycles I have calculated. And this is the time period required for each and every instructions I have calculated and given it all here. And these are the addressing mode used, types of instructions, and flags. Mostly no flag affected actually. And coming to the result, as you can see, we have performed the 8-bit numbers and executed using the Kale software, and the results are verified using manual calculations. Now coming to the second question, we have to load the values from R0 to R4, then have it to be pushed into the stack using Kale software. As you can see, I am using the same IC and same Kale software. And this is the numbers which I have decided to push. I am using this 22 because of my registration number 19BEC0522. So this 22 and again I have 10, 10, 10 like this I have kept. These are some random take numbers according to my registration number. And this is the flow chart. And this I can start the program. And this is the first numbers which I am going to be pushed. And I'll be using mnemonic move and assign the values to registers R0 to R5 and I'll usually push those force value into the stack after debugging the program and make them selected and I'll stop it. As you can see in before I have explained about mnemonic, comprehend, mission cycles and flags comments, right? It's the same here. I have given each and everything and I have also provided the Excel sheet so that you can get a better understanding of the code. And this is the output I have got after my results. As you can see, this is my code and it has no manual calculations actually. Hmm. And this is my code as you can see. And after this I have executed it. After executing, you can see all my values have been coming here, shifted to here. And this is the inference and total time period. I have mentioned it here. And each and every one is how many mission cycles it took and time took to execute. And These for something better understanding of the instructions and flags. As you can see, no flag is affected here. So ag update and total amount of time required is calculated and addressing modes used and data transfer. So coming to the result, as you know, we have pushed operators of 5 8-bit numbers is executed using the Kale software and manually. And now coming to the third question, uh, it asks us to write 8051 ALP to set a stack pointer, store different values in different location of RM, and then all values to be popped out into the registers using Kale software. Kale software and tools required, we have used the same Kale software and the same IC. And this is the algorithm as you can see. Coming down to the flowchart, it's the same as the push, but here we go on the backward. And I have given this table for a better understanding of the code, and I have mentioned each and every use of instructions, operand and the comments, and the flags that are affected. And I have also given an Excel sheet link so that you can get a better understanding at this. And this is the output I'm going to get after executing the program. And I have given my registration number here in the code. As you can see, my registration number is 19BEC0522. I have used move and put. In the previous question, we have used move, and here we are using pop. So it doesn't make much difference. As you can see, uh, I mean, in the previous question we have used push, and in this question we are using pop. When we are using pop, the registration number is coming from down to up, and when we are using push, the values are coming from up to down. And now coming to the inference, this is the total time period calculated and the time required for each and every instruction given in the table and time to execute. Second, the amount of time required, and this for the better understanding I have told you before. And as we know, no flags are affected, and total time required for the assembly programming is just 19.548 microseconds. And now, as we know, we have done it the proper operator for 5 8-bit numbers and is executed using Kale software, and the results are verified manually. And these are the same. We are going to use again pop, and this time we are going to use push also. I'm going to use my registration number in it. As we know, it's the same IC and the same software we are going to use. And you can see that then this is my flowchart, and this I've told you my program. And for better understanding, I have given my Excel sheet also. And now coming to manual calculation, there is none. This is my code. And coming to the push statement, when I executed push, my registration number is coming from up to down. And why I executed my pop, the registration number is coming from down to up. As you can see, I have also highlighted it for a better understanding and for a better view. And this is the inference and the result. We know it. I have executed each and everything manually. Next fifth, it is to write a set of values into the register and push them into stack and again pop them back into registers using Kale software. Now let's see how the code goes on. And this is the flowchart. We know it. I have explained each and every bit of it so that you can get a better understanding. And this is a program. Each and every line of the program is given an explanation, comments, and flags required. And for a better view, I have also given an Excel sheet link. You can go through it. And this is the output I'll be getting after the execution of my program and manual calculation is done. Coming to the observation, this is my code. I have also given the comments, operahands, as you can see, so that you can understand just by seeing it. And this is the snips after the execution. As you can see, this is my result. And as you know, we have used push and pop operator is executed using the Gale software and is verified manually. And thank you for seeing this. I hope you like this video. And let's end this section. If you have any doubts, please mention in the comment section.